All right, today we're finding probabilities. We're going to look at events and to find the probability of certain things. All right, so here's our problems we're going to work on. First one here, a probability experiment consists of rolling a fair 10-sided die. Find the probability of the event below. Here's my event, rolling a 3. All right, so we have a 10-sided die. We want to roll a 3. All right, this is a theoretical probability or classical probability. All right, so how many 3s do we have? Well, there's 1 3. So probability of getting a 3 is going to be, there's one of those out of this 10 total sides. So 1/10, which would be 0.1. Okay. Number 2. Probability experiment consists of rolling a fair 6-sided die. Find the probability of the event below. Rolling a number greater than 3. All right. Probability that we're greater than 3. All right. So it's 6-sided die. So that means in the bottom here we have 6 total possibilities. Greater than 3 of the 6-sided die. That means we could have a 4, a 5, or a 6. So there's 3 possibilities there. So this is 3 over 6, which is 1/2. But it wants it a decimal, so you're going to have to put 0.5. Okay. I think these first ones are all classical probabilities. Let's look at number 3 here. A probability experiment consists of rolling a 6-sided die. Find the probability of the event below. Rolling a number less than 4. Okay, so we want the probability less than 4. All right, this is a regular 6-sided die like we usually have that we deal with. Okay, so that means we have 6 total outcomes possible. Okay, now less than 4 on these 6, well, a 3 is less than 4, or a 2, or a 1. These are my possibilities for this event. So there's 3 of those. And this would be 1/2 as well as the last one. So this is 0.5. Okay. Number 4 right here. A probability experiment consists of rolling a fair 18-sided die. Find the probability of the event below. Rolling a number divisible by 4. All right, so the probability of a number that's divisible by 4. Okay, it has 18 sides, so we know we have 18 total possibilities. All right, how many are in this event here where it's divisible by 4? How many of those do we have? So 18 sided starting at 1. All right, we've got 4 divisible by 4. Then we have 8. Then we have 12. And then we have 16. And the next number would be 20, which would not be in the 18 sides. So here's 4 possibilities. This would be 4 over 18. Okay, now I don't know what that is dividing right off. 4 divided by 18 is 0.22222. So this is, and look, it says 3 decimal places. Now if you just put 22, it'll count it wrong. You have to have 222. These other ones, 0.5, they're terminating decimals, so I don't think you'd have to have the zeros on there, but you know, if you do, just put the zeros on it like that. Okay. All 4 of these were classical probabilities. Now I think we get to number 5 here, we're going to start looking at some empirical probabilities. Number 5 here, a company is conducting a survey to determine how prepared people are for a long-term power outage, natural disaster, or a terrorist attack. The frequency distribution on the right shows the results. Use the table to answer the following question. What's the probability that the next person surveyed is very prepared? All right, so very prepared is right here, 261. Now, if you noticed, I've already added these up. And again, when we add these up, we want to do this twice. Make sure we've got the same number both times. You know, could make a mistake, add them just one time. So always double check, make sure you add twice. But my probability that the next person surveyed is very prepared. Okay. So that means I'm going to have the frequency of event E, which is 261, divided by the total frequency, which is 2131, and I divide those. All right, so let's see here. 261 divided by 2131, and I get this 0.1224. Does this 4 make that 2 go up or stay? It stays, so it's going to be 0.122. Okay. Now here's another one, and again we got an empirical probability here with the frequency distribution. It shows the number of American voters in millions according to age. To find the probability that a voter chosen at random is in the 18 to 20-year-old age range. So what's the probability that the next person is 18 to 20? Okay, so the frequency of the event E, right there, 4.4. Divided by the total frequency, which is this number right here, 135.5. Okay, so the frequency of event E divided by the total frequency. So let's see here, 4.4 divided by 135.5. And I get this right here, 0.32. Does this 4 make the 2 go up or stay? It stays, so 0.32. All right, so 0.032. There's my answer. Okay, let's go to the next page. All right, number 7. Use the company frequency distribution, which shows the number of voting age citizens in a certain country in millions by age, to find the probability that a voting age citizen chosen at random is in the age range of 45 to 64. All right, so what's the probability? 45 to 64. Okay, well, 45 to 64. The frequency there is 72.7. Total frequency right here, 212.9. All right, so I divide those. All right, 72.7 divided by 212.9. And I get this right here. All right, I want 3 decimal places. Does the 4 make the 1 go up or stay? Well, it stays, so it's 0.341. Okay. All right, going on down here, number 8. Use the frequency distribution to the right, which shows the number of voters in millions according to age, to find the probability that a voter chosen at random is in the given age range. Okay, look, look here now. Not between 21 and 24. All right, so we want the probability 21 to 24, complement of that is what we want. All right, so that's going to be 1 minus the probability of this, which from 21 to 24 is 8.3, and the total, there you go, 141.5. All right, so right here, this is the probability that a person is in that range. Of course, we want the complement. We want them to not be in that range. So I have to do 1 minus this, whatever that is. So what I can do is I can just punch it in all at once. Okay, so it's going to be 1 minus 8.3 divided by 141.5. And I get this right here, 0.941. Wait a minute. does the 3 make the 1 go up, and it just makes it stay. So 0.941. Okay, now let me do this right here. What's the probability that the person is between 21 and 24? All right, that's going to be the 8.3 divided by 141.5. So if I do that, 8.3 divided by 141.5, I get this right here. Here's the probability that they are in that age range. 0.59. 0.059. The 6 makes the 8 go up. All right, so the probability that they're not would be 1 minus that. So if I do 1 minus, I get the 941. Okay, so you do it 2 different ways if you'd like. Number 9 is the last one. Use a frequency distribution to the right, which shows the number of voters in millions according to age, to find the probability that a voter chosen at random is in the given age range. All right, we got another not. Not between 18 and 20. So probably that they're between 18 and 20, the complement of that, which is going to be 1 minus the probability that they are between 18 and 20. Okay, the complement is 1 minus the actual probability of that. So let's do this. 1 minus, all right, the probability that they're between 18 and 20 is going to be 7.4. See, 18 and 20, 7.4. And the total is 150.4. I added all these up previously. And then I can just punch this all in at one time. All right, so I'm going to go 1 minus 7.4 divided by 150.4. And I get this right here, 95. The 7 makes the 0 go up to a 1. So 0.951. Okay. All right, so that's how you find probabilities. And really simple. If you need help, though, let me know, and I'll try to help you with all I can. Have a good rest of the day.